For 37 years, the entire field of low-energy nuclear reactions has been dismissed as a scientific impossibility, careers destroyed, funding denied, research buried, and yet the physics never stopped working. What if the reason fusion energy has not arrived is not because the science failed, but because the entire approach was wrong? What if the answer was never a reactor? What if the answer was a semiconductor? In 1989, Martin Fleischmann and Stanley Pons announced they had observed nuclear fusion at room temperature. The scientific establishment rejected them almost immediately. Funding vanished. The field was branded as pathological science. The U.S. Patent Office created a secret internal policy to automatically reject anything related to cold fusion. But one researcher in France was paying attention. Not to the controversy, to the physics. Fabrice David is an independent scientific researcher, inventor, and strategic advisor with more than 2 decades of experience spanning fusion-related energy science, advanced nuclear phenomena, propulsion systems, and applied biotechnology. He has authored or co-authored more than 130 scientific publications on ResearchGate. He holds numerous patents across advanced energy systems, nuclear science, and experimental physics. While the rest of the field spent decades measuring heat, David saw something everyone else missed. He recognized that if nuclear reactions were occurring inside a metal lattice loaded with deuterium, trying to capture that energy as heat was the wrong approach entirely. It was the same mistake as trying to capture sunlight by boiling water instead of building a solar cell. David's insight was the photovoltaic bypass. If you place a semiconductor in direct microscopic contact with a metal loaded with deuterium, the localized nuclear reaction acts like a light source at the atomic level. The energy excites electrons directly across the band gap of the semiconductor and into the conduction band. You capture the energy as electricity before it ever has a chance to decay into heat. In 2009, David and his co-author John Giles published the foundational paper, Self-Polarization of Fusion Diodes. That paper laid the exact blueprint that American fusion is scaling today. Their devices were powder-based diodes, semiconductor powder in contact with palladium powder loaded with deuterium, no external power input, no moving parts. And yet, when exposed to deuterium gas, these devices generated a spontaneous, self-sustaining voltage of approximately 0.5 volts per junction, electricity from nuclear reactions at room temperature, directly, cleanly, continuously. When critics pointed out that the power output was only microwatts, David invoked the Fermi defense. He compared his 1-gram palladium diode to Enrico Fermi's first nuclear reactor, the Chicago Pile, built in 1942. That reactor weighed 400 tons and produced barely enough power to light a single light bulb. David's diode, gram for gram, matched Fermi's energy density precisely. The physics was real. The engineering was just beginning. David did not stop there. Over the next 15 years, he iterated through 5 generations of the fusion diode, Mark I through Mark V. Each generation refined the junction geometry, improved the deuterium loading, and increased the electrical output. The Mark IV was independently measured by Jean-Paul Biberian, one of the most respected experimentalists in condensed matter nuclear science. The data confirmed spontaneous voltage generation sustained over time in a sealed deuterium atmosphere. The Mark V diode, described in American Fusion's Investor Materials, produces approximately 15 to 20 millivolts per diode and 1 to 5 milliamps of current. It has been photographed, published, and presented at peer-reviewed international conferences. It is not a simulation. It is a working device. But David understood that a single diode was not a product. The diode was proof of principle. The product would require a manufacturing revolution. This is where the transistor analogy becomes precise. In 1947, the first transistor was a crude point-contact device built on a slab of germanium. It barely worked, but the physics was sound. Within 2 decades, transistors were being printed by the millions on silicon wafers, and the vacuum tube was dead. David is executing the same transition. He is moving from hand-built laboratory cylinders to 300mm silicon wafers manufactured using standard semiconductor processes. Vacuum sputtering, photolithography, the same tools and foundries that print every microchip on Earth. The architecture is called monolithic multi-junction, MMJ. Instead of one diode, you print millions. Layers of gold, palladium, and silicon deposited in a precise geometry that creates a 3-dimensional superlattice of fusion junctions. Each junction produces its electron kick via the Entanglement-Gordon effect. When hydrogen or deuterium enters the lattice, it creates a spontaneous transfer of energy directly to the electrons in the semiconductor. Direct current, 0.7 volts. No heat loop, no steam, no turbines, no moving parts of any kind. The mathematics of this architecture is what makes it a monopoly. One 300mm wafer contains between 300 and 450 visible power cells. Each cell is an array of thousands of microscopic junctions layered by vacuum deposition. The total density reaches millions of integrated diodes on a single plate. And here's the critical breakthrough. The power scales linearly. If one diode produces 1 microwatt, then 10 million diodes on a wafer produce 100 watts of constant direct DC power. This is not theoretical. This is arithmetic. And it is the property that makes this technology fundamentally different from every other fusion approach on Earth. Every tokamak, every laser facility, every magnetic confinement experiment scales nonlinearly. Double the size, triple the cost, and you might get a fraction more output. David's architecture scales like a printing press. Want more power? Print more junctions. This brings us to Bergamo. On March 24th through 26th, 2026, the 17th International Workshop on Anomalies in Hydrogen-Loaded Metals will be held at the Chilometro Rosso Innovation District in Bergamo, Italy. This conference has been the premier scientific venue for condensed matter nuclear science since the workshop series began in Asti, Italy in 1993. It is where the most rigorous experimental work in this field is presented, debated, and validated. Fabrice David is not simply presenting a paper. He is installing what the company calls life devices in the Prometheus laboratory on site. These are not static displays. They are active, functioning generators connected to sensors and multimeters, providing real-time feeds of voltage and current for the entire duration of the 3-day workshop. The purpose is transparency. No hidden power sources, no external wires. Independent experts can inspect the setup directly. The devices are designed to demonstrate continuous operation without depletion, proving that the nuclear lattice reaction is sustained and stable. This is the direct answer to the scientific community's demand for reproducibility and long-term performance. The target is 100 watts or more of stable output from a silicon wafer. If achieved, it will be the first demonstration of wattage-scale power from a solid-state fusion device in history. But the significance extends beyond the power number. Professor Konrad Czerski of the University of Szczecin will be on site. Czerski's research group published a landmark paper in Physical Review X in October 2025 confirming the experimental signatures of a new reaction channel in deuteron-deuteron fusion at very low energies. Specifically, they observed electron-positron pair creation from a threshold resonance in helium-4. This is the Czerski-Vallet effect. It provides the peer-reviewed nuclear physics mechanism that explains how David's diodes work. The reaction does not produce neutrons. It does not produce dangerous gamma radiation. The excited helium-4 nucleus de-excites by emitting electron-positron pairs. The energy goes directly into charged particles. This is why the device is clean. This is why it needs no shielding. And this is why the energy can be captured as electricity rather than heat. If Czerski's team provides co-observation data at Bergamo, confirming that the output signature from David's wafer devices is consistent with the electron-positron pair channel, it will bridge the gap between a laboratory anomaly and mainstream peer-reviewed physics. The technology ceases to be speculative. It becomes a verified semiconductor product built on a published nuclear reaction mechanism. Now consider what this means at scale. David has filed patent applications covering the specific geometry of the stacked junctions, the deposition sequence of the gold-palladium-silicon superlattice, the series parallel interconnects that sum voltage and current from millions of nanoscale junctions to reach usable output, and the Muehlner shock electrolysis trigger system that allows devices to be tuned and repolarized at the chip level. The January 2026 priority patents protect the core architecture. Because the MMJ technology uses standard semiconductor manufacturing processes, American Fusion does not need to build its own factories. It licenses the recipe to existing global foundries. The business model mirrors ARM or Qualcomm in the mobile semiconductor space. A royalty on every energy chip in a drone, a medical implant, a satellite, a smartphone, or a grid-scale power block. American Fusion, trading under ticker RNWF, has filed over 238 patent applications. These patents lock key categories across automotive, grid power, space, and defense. Any device that requires a never-die battery or an always-on grid solution will need to license this technology. The company describes two distinct product lines built on two different physical effects for two different purposes. The first is the solid-state fusion generator, the energy chip, using the Entanglement-Gordon effect to convert Lennar energy directly into electricity via semiconductor diodes. The second is the Kepler engine, a subcritical hybrid reactor designed for space propulsion, using the Parkhomov-Belousova effect to generate neutrons that standard Lennar does not produce, enabling lightweight thrust without moving parts. On February 23, 2026, American Fusion announced the appointment of Fabrice David as an independent director of the company. He will provide scientific and technical oversight, intellectual property strategy, and independent governance as the company advances toward commercial deployment. The roadmap is explicit. The Life device demonstration at Bergamo validates the linear scaling. If the devices show consistent power output relative to junction density over 3 days of continuous operation, the next phase is the 100 megawatt power blocks targeted for late 2026. Factory-built, modular, deployable. For more than 2 decades, Fabrice David published, patented, and iterated through 5 generations of fusion diodes, while the world argued about whether the physics was real. Konrad Chersky's Physical Review X paper settled that argument. The electron-positron pair channel exists. The nuclear mechanism is published. The cylinder was the proof. The silicon wafer is the product. We are not witnessing the promise of fusion energy 30 years from now. We are witnessing the transistor moment for nuclear power, the shift from reactors to semiconductors, from football stadiums to silicon wafers, from heat engines to direct electrical conversion. March 2026, Bergamo, Italy. The Prometheus Laboratory. The world sees the energy chip go live. RNWF, American Fusion. Not financial advice. For informational purposes only.
Enter script for scene 2. Enter script for scene 3.